So in this video I'm going to show you how I use Delph to debug a problem in my Go code that I was using to solve this particular dynamic programming problem. So I've given you the reference of the problem and also the statement. Feel free to pause the video and go over the statement, but I will I will just give you a quick overview so that I can talk about more on Delph. So basically we have a number of stairs and we can jump either one or two steps, and the energy consumed for the jump is given in a height array. So whenever a jump occurs, the difference between the two energy is the energy consumed to jump from I to jth step. Now we are asked to get the minimum energy from start to the end step. Now this is a famous dynamic programming problem, and um, there are multiple solution videos, but we are not here to talk about the solution. I'm just going to show what I am trying to do in the code. Uh, so just to visualize this, so we have input of the only input of this height array, which shows that how much energy is taken uh, for each step. So if you are going from here to here, the energy spent is the difference between these two values, the absolute difference. So there is another constant that you can take either one jump or two jumps. So suppose you want to jump from the first element to the third element. Now you have to how do you calculate that? So basically, uh, if you see, in order to come to 3, you have two options. Either you come from 0th element to first element, and then first element to third element, which will consume 2 minus 1 1 and 1 minus 3. Absolute value would be 2, so total 3 energy. So this is one way. Another way would be to jump directly from 2 to 3, which will take only 1 energy. So the minimum of these two will be 1. So this is how this dynamic array is populated. So basically you memorize whatever energy you have calculated and use that to solve for higher values. Now if you are so the base case, if you see the base case, if you are jumping from the first element to the first element, so basically you have a single digit array, the jump will cost you 2 minus 2, that is the only energy that will be consumed in 0. So in the DPR I am writing down the minimum energy that is required to jump to the element from the starting element. So if you are jumping from starting element to 0th element, that is the same, it takes no energy. And if you are jumping from say 0 to first element, that has only one path, that is 2 minus 1 1. So these two are the base case, and based on that you calculate everything. This is the initialized value. When this get calculated, you can return this as a answer. Now let's try to see what we did in the program. So basically I created that energy, or the DP array, which holds the minimum energy to jump in ith element. And apart from the first element, everything is initialized to -1, so that it shows that the energy has not been calculated yet. Now I have defined a function here so that I can call it recursively in this manner. So I have a check that if the value that I am looking for is not calculated, then do all this calculation, and if the value is already there, then just return from the array. So here is how we are optimizing the time complexity. But that's a different topic. So how is that calculated? So there are two possibility to jump to a index I. So either you can take one step, so you have already reached step 1 and you can jump one step to it, or you are standing at I minus 2 and you can take a jump directly from I minus 2 to I. So the first possibility says, okay, calculate the energy to jump till n minus 1 and then the difference from n minus 1 to nth index. Or you have a possibility 2 where you are standing two step behind and you calculate the energy to be on I minus 2 and the heights, the difference between the heights that you are going to consume. So there is a check here. So if n greater than 1 only, then you can calculate it, and then finally whatever is the minimum energy, you put it in the array. So it looked good to me. I did dry run on my head in my head, but I could not see that it has some edge cases that where it does not work. So let's see. Let me run the program first. So I can see the test is failing for a couple of cases. So the basic case that I was showing you has passed, but it fails when I have only two cases, right? So let's see what it tells. So it shows you expected 9 got 0. So let's look at the test case. So this is my test file. So 2 stair ascending and 2 stair descending both failed, saying that expected 9 got 0. Expected 9 got 0 both for ascending and descending. So let's see. So I have two weights 1 and 10, and if I draw the diagram, I can see. So again, if you are calculating the minimum energy to jump from first element to the first element, so it is 1 minus 1 0. But if you are coming from 1 to 10, you have only one option. So 1 minus 10, the difference between these two energy is 9, so we are taking absolute value of that, so plus 9. So this should be the answer, right? But somehow we are getting 0 instead of 9. So let's see. So I run the same test, but now with delve. In delve I can specifically say that, okay, run this test, and so this is a feature for table driven test. So you can specify which test you want to run. I got the test name from here, so you can easily copy this and put it here. And when I start this, I have a new window. So let's set a breakpoint. So I'm going to put a breakpoint in 26, which is, if you see, line number 26. Now I'm going to say continue. Now whenever your program reaches this step, you get to see what's happening and check the in-memory values real time. So I'm going to say print locals. At this point I have these variables dp, and so let me show you that. So if I see the dp of length 2, I have these values. This is expected because of this initialization. Now what happens when we go inside the function? Next step. So okay, so I think for the first time this is the function definition, and we do not run anything here. But when I say return n minus 1, we actually call the function. So next step. So yeah, again, next. Now we are actually inside the function, and let's see what is the value of n. Print n. So n is 1 as expected. So since the length is 2, I'm calling it with f2 minus 1. So n is 1. Now what happens when n is 1? If you remember the dp array, the first element is minus 1, so it is not going to get returned from here. It is indeed going to calculate the value of p1. So if I do next, now we are standing at p1, and let's see what is happening here. So we are going to calculate f of n minus 1, that is 0, f of 0 plus difference between height n and height n minus 1. So height 1, and of course let's print these values. So my n is still 1, and if I print heights, I can see the difference is going to be 10 minus 1. So absolute value between them is 9. So this plus 9, this should be our content of p1. Now if I do next, there is a function called fn minus 1 again. So we are calling the function again. If I do next and print n, so I can see we have called this function is 0, and for the 0 it is well defined. So for 0, if we see the dp array is 0, so it is not minus 1, it is going to return the dpn, so we are going to get 0. So if I say next, now I should have a value of, so when we return back to here, we should have a value of 0 plus 9. So let's see what happens here. Now print p1. Okay, maybe we are still in that function, right? So when we do print n, now we are already returned, but we haven't got the value of p1. So I am doing next. So when we reach the next line of var p2, now we can print p1. So p1 was not initialized before, that's why we got this error, could not find symbol for p1. Now we can see p1 is actually 9, so we are indeed calculating 9, but what is happening now? This check is going to execute. So if I do next, it says if n greater than 1, then do this, but as we printed n equal to 1, so we are going to come here. Sorry about the typo. So let's see what is the value for p1 and p2. Maybe I have to print separately. So okay, now I see the problem. So we are comparing with p1 and p2, but when I initialized it, it is 0. So whenever you have a weight of positive integers, you are always going to get 0 irrespective of what your calculated value is. So now we know the problem here. Now if I do next, and at this point if I say print dpn, I can see it has stored 0. So okay, I was going to print I wanted to print dp, so both are 0 0. Now we are returning this 0, and instead of 9 we are getting 0. So I'm going to fix this by whenever I'm initializing this, I'm going to initialize it with max int so in this way p2 is going to be initialized with the maximum possible integer value, and whenever I compare it with the calculated p1, if all my weights are using integer and positive weights, then obviously I'm going to get p1, not the p2, which is the initialized value and not a true weight. So let me quit this terminal and run the test again. So go test, voila, everything has passed.